In this video, we are going to move away from linear equations as the beginning equation and move up to a type of equation called a quadratic. You will start to notice terms with an x squared being in the equations, and so those are called quadratic equations. Now with these, there's several different ways to solve them, so we're going to go through some examples of each technique used to solve these. One technique is to use factoring. Now, if you're able to factor, that will break a quadratic down into smaller linear factors. And since we already know how to solve linear equations, it makes it easier to find your solutions. The top left example, we have 8x squared plus 2x equals 0. Both of these terms are divisible by 2 and x. 8x squared divided by 2x is 4x. 2x divided by 2x is 1. That creates two factors, both of which are linear. 2x equals 0 whenever x equals 0. 4x plus 1 is equal to 0. By subtracting 1, you have 4x equals negative 1. Dividing by 4, you get x equals negative 1/4. Quadratic equations can have a maximum of two solutions. Most of the time, there are two solutions that you find that are unique. In this one, 0 and negative 1/4. Each one of those, if subbed in for x, creates a true statement. The upper right, we have a quadratic equation. This one's a trinomial, and when we factor it, we can factor it as x plus 2 times x plus 2. You can check your work by using the FOIL method. X times x is x squared. 2x plus another 2x is 4x. And then 2 times 2 is 4. Once you're sure that you factored correctly, if your factors are identical, you only need to take one of them, set equal to 0, and solve for x. This one has a repeated solution of negative 2. In the example below, we have a binomial quadratic equation. Binomial meaning there's only two terms equal to 0. Both of these are perfect squares. Square root 16x squared and you get 4x. Square root 25 and you get 5. Now there's no middle term with an x, so you got to be careful. The outer and the inner terms must zero each other out. And they do if you put a plus and a minus sign in the parentheses. The outer is negative 20x, the inner is positive 20x, and that zeroes out. So no x term, we need to make sure that those cancel. 4x plus 5 is equal to 0. Subtract 5, divide by 4 when x is negative 5/4. 4x minus 5 is equal to 0. When we add 5 and divide by 4, we get x equals 5/4. So if you run into a difference of two perfect squares, your answers will have opposite signs. In the equation to the upper right, if your terms are not all on one side equal to 0, move all your terms over so that they are. I'm going to add x squared to both sides, and then I'm going to take away 5x from both sides. Once all your terms are on the same side, then you can attempt to factor. X squared breaks down into x times x. Now with trinomials, three terms, you have to make sure that the pair of numbers you pick have to add up to this negative 5, but you also got to make sure your product is positive 6. And you guys helped me out in class. We determined negative 2 and negative 3 were the two numbers that we needed. If you add negative 2 and negative 3, you get negative 5. If you multiply them, you get positive 6. Set each factor equal to 0, solving for x, you will get 2 and 3. Another technique for solving quadratic equations is extracting square roots. Now, these have kind of a small window of opportunity for usage, and really, to be honest with you, the technique is needed when we discuss quadratic formula. For now, just know that if you recognize x squared equals a number, or just anything squared equal to a number, that you can use extracting square roots. The formula, and let's see, let me sketch this in the middle. If you have some algebraic term squared equal to a number, that algebraic term will be equal to the positive and negative square root of that number. I mentioned it down here at the bottom of your screen, but I didn't do that sketch up at the top. So let's get back to our problem. X squared equals 169. That tells us x will be equal to positive and negative square root of 169, which is positive and negative 13. Those are your two solutions. In the upper right example, 2x squared equals 36. Let's first divide both sides by 2. That gives us x squared equals 18. Now we have the format, algebra squared equals a number, so x is equal to plus or minus square root of 18. Now, I mentioned in class that there's nothing wrong with having your solutions as positive and negative square root of 18. If WebAssign requires a reduction, then your 18, because it can be written as 9 times 2, you have a number that you can square root. Square root of 18 reduces to 3 square root of 2. Don't forget the plus minus. That preserves the fact that there's two solutions. So these two answers are just fine. Square root of 18 and negative square root of 18, those are totally okay. If WebAssign makes you reduce, then what they're expecting is 3 square root of 2 and negative 3 square root of 2. Our example at the bottom, x minus 6 quantity squared equals 36. This is still under the right format, an algebraic term squared equal to a number. So x minus 6 is equal to plus or minus square root of 36. Well, that's plus or minus 6. When you isolate x, it takes adding 6 to get it by itself. Now be very careful here. When you solve for x on extracting square roots, whenever you make your final move to isolate x, adding 6, make sure you add the 6 in front of the plus minus. So this little maroon colored 6 is that one. Plus minus 6, you want to leave it in the back because, again, we're after two solutions. When you add the numbers, 6 plus 6, you get 12. When you subtract them, 6 minus 6, that's 0. So I've used a plus sign and a minus sign. I've circled them to show what operation was being done. 6 plus 6 is 12. 6 minus 6 is 0. 12 and 0 are your solutions.